we can go ahead and begin. The sooner we start, the sooner we can be done. So, good morning, everybody. How you doing? What do you think of graphing polynomials so far? Any good? Terrible headache? Not too bad? Lots of fun? All of the above? Well, whatever your answer, we're going to make it a lot better. Because today we're going to graph them with a calculator. So, no, that's geometry. Let me pop open my document here. Here's what we're going to do today. We're going to take the same document, the exact same set of functions to graph that you produced an approximation of before, except now we're going to break out the TI-84. We're going to graph that sucker exactly, and then you're going to take that graph, that image, put that on your page, and then we can actually start to do some of these fancy things, approximating the zeros based on the graph, approximating the maxima and minima based on the graph. And that's probably the most important one, I would say here, because we have no other tool to do so. We can find and solve for zeros algebraically, right? We have all those tools we've already dealt with. But the maxima and minima, where if, for example, to the fourth, where do these things end up? We have no idea, unless we get a much more accurate graph. So let's whip out that calculator. I have mine here, and let's practice graphing this guy. What are the things we need to deal with? Honestly, it's not too much. A good old y equals. Okay, make sure all your plots are off. Make sure this is set to solid line, your color, and this should fill in as soon as I start typing something. So we want negative x to the fourth power. So I'm going to use a caret to the 4. And notice on the 84, it actually moves the cursor up into the exponents. I can put more things inside this exponent here if I wanted to. Okay? But we don't want to. We want to move out of the exponent. So arrow key to get back down. And I'm typing in function number 2 here, just as an example. So then plus x cubed plus 2x squared. All right, so there's our function, and we could just graph from here, but let's double check our window. What's it set to? 10s all around, so this is the standard window, right? If you press zoom and 6, standard entry there, that'll get you the 10 by 10. Let's see what that looks like. That's not bad. That's not a bad view, right? I would say I can see all the features. We can definitely tell, right? It's both ends going down, okay, as we would expect with a negative even power. And we can see the turn here. That looks like a 0 there and a turn up here. We should know that one of the zeros has to be 0, 0, because every term had an x. We could factor out the x there, and so we know 0 should have been one of these solutions at least. And we can probably see there's another solution, there's another solution. I would rather zoom in a little bit. So let's play around with some of the zooms until we get a real good picture here. The given graph page on the worksheet here goes from -8 to +8 in both directions. And I think that's consistent on all of these? Yes. So we'll try a couple other views here, but we're probably going to settle on that because that's going to make it the easiest for us to transfer. We can draw exactly as we see it on the screen. But another one of these here, zoom square, is going to be pretty similar to standard, but what it does is it sets the vertical and the horizontal to be an equal number of pixels, right? So it's not stretched by being presented on a widescreen format. Okay. So if you want a truer image of that, that would be the one to go with. And then you could just say, okay, this goes out to 10. I only need 8. You can cut that off, zoom in a little bit. In fact, we can literally zoom in. Just press 2. And where do you want to zoom in on? Just on the center. Enter. But it really zooms in. We have a good view here, knowing that every tick is at 1. I believe it's at 1. How do we tell? Window. X scale is 1. Y scale is 1. So this tells me a pixel mark at every 1. Okay, so yeah, it looks like I have roots at -1, +1, and a double root at 0 because it bounces right there. But maybe that was too far for us. Let's try a different zoom. I like the newest one on these guys. I don't think I had on the 83. All right, is the zoom fit. So number 0 there. And that's going to stretch the graph to what the calculator thinks is the best view to see everything happening there. And honestly, in this case, I would say that's an awful view. You can't see the bends in here. It's squashed all the interesting stuff just into the top right there. That looks terrible, right? So here's my recommendation. Since you're copying down to an 8 by 8, or sorry, 16 by 16, from -8 to +8, why don't we set that as our window? We can force this to be whatever we want. Say the x minimum is -8. The maximum is +8. Make a distance between each tick 1. It even tells you right there what it is at the top of the screen. Wow, it's so helpful. Okay. Same with y, -8, maximum 8, scale 1. You do not have to change the resolution. This is across how big a pixel itself is. So don't ever mess with that. And the rest of them also we don't need for basic graphing here. So now we're going to get something back to this. We get the whole picture right there. Okay, so again. Oh, I forgot to switch back to calculator. Oh, why didn't you say so earlier? I've been doing this the whole time. Ah, no visual. No. All right. Oh, where did I leave off? Okay, we have started with zoom fit, or zoom standard. And then here's zoom square. Very similar, but notice the distance vertically and horizontally is now set to be the same, so you don't get that widescreen stretch. Calculator also has zoom. If I go down to 0, here it is, zoom fit. What they believe to be the best image for our graph, and that's pretty crummy, because it's all squished up at the top. We could go back. Oops, what happened here? I broke it. I clicked things too fast. Stop. Quit. Y equals zoom 5. There, back to standard. And you could zoom in if you wanted to, right on there to get a blown up view. Or we could set our window to be exactly matching our graph. -8 here, +8 for the max x, keep the scale at 1, -8 to 8. And then when you graph, there's what you'll get. Okay, now we can all see that, and we can transfer it to our page. So I would start by drawing in, I'm going to switch back to my iPad cam here. I would start with those zeros. You know it crosses there. You know it crosses here and here. No, that's not 1. That's 2. Sorry. +2 there. Right? And what we need then is we need to know how far up do these have to go. So look at the graph. Looks like this side is not quite to 1. So I'm going to say it goes up halfway there. And the other side, 1, 2, 3, not quite to 3. And about up there. So that's what I'm going to be aiming for. So we'll come up through here, bend there, curve back around, up to that point, curve back around, down through the 2. And then we can just extend these nice and gentle like that. Is it perfect? No. The calculator graph is perfect. But we're not aiming for perfect. We're aiming for good enough to get an approximation and accurately say, yeah, I can actually see from this graph where the zeros and the maximum and minimums are, right? I can see that we've got our zeros at -1, 0, and 2. I can see that my maximums my maximum values, that is to say, or it looks like about 0.5 and 2.8 or something, you know, almost 3, but not quite. And the minimum, we already knew that one. If you go through 0, 0, that would be minimum of 0. Okay, so that's the extra information that we can now read off of the graph fairly easily and fairly confidently. Of course, if you want even more accuracy, go back to the calculator. Instead of just the graph button, use the trace tool. And then you can run your little cursor along here and find out. Watch that y value. 2.5, 2.76, 2.83 increase, 7.1, that's a decrease. Okay, so our maximum was up here, 2.8. Hey, that was pretty good. I didn't even check this before. And I got 2.8, right on. And same with over here. An arrow on over 0.3, 0.37, 0.39, 0.31. Oh, back to 0.39. Okay, so to 1 decimal place, that's more like 0.4. Round that up. Because remember, this itself is not the exact answer either. This is not the maximum. Don't confuse that. If you're using the trace tool, this is still an approximation, because the calculator is going from 1 pixel to the next pixel. That's as accurate as it's going to get. So if we want more accuracy, we should zoom in. Zoom in on, well, actually, we can zoom in on that guy right there. And now when we trace it, 3.9, oops, I'm not tracing. There we go. 3.96, 3.93. So now we get 0.3969995, right? That's even more precise, the value of the local maximum right there. Now, of course, we can also ask the calculator to calculate it exactly for us if you want to go that far, but we're not going that far. We're going visually from the graph, not any computation. But let's see, just for fun, calculator, can you find for me the exact thing for that. I want you to calculate a thing. Oh, look, right up there. Second trace. Calculate the maximum, oops, between here and there, and it's about that much. Whoop. And it's going to be more precise. Okay. This is their pretty confident answer. I'd say that's pretty darn close to 0.4. I would round that up to 0.4, but 0.3970463, right? And even the x value is not like an even half or something simple like that. So spoiler alert, you're going to need calculus to have any better tools at finding those values without the calculator. But for now, this is all we need. Okay, further questions there? No? All right, so then back to here, your job for today. Revisit this exact same worksheet. Make a better graph with the help of the calculator. And then give me better approximations for the zeros and the maximum and minimums. So you can just jot out this information right here. You do not have to rehash the additional things that we already did yesterday. The only duplicate is the graph. So same picture, better resolution, new information. All right, do that for all 8 of these. And that's all we have for today. Final call for questions? No? All right, then I will leave you to do the rest.